that moment when you type a prompt into ChatGPT, Claude, or Gemini, hit enter, and boom, an essay or a perfect block of code just magically appears on your screen? We've all seen the incredible results. But what is actually happening behind the scenes in those few seconds? Today, we're going to look past that simple little chat box and dig into the true architecture of intelligence. Welcome to this explainer. I am so excited to guide you on what's going to be a step-by-step digital journey straight into the brain of a large language model. Over the next few minutes, we're going to completely demystify how these systems actually work. We'll explore how they're trained, how they process human language using things called tokens, and exactly how they make those incredibly accurate predictions. Our goal here is actionable understanding, so you can truly grasp the technology that is quite literally driving the modern world. Let's get into it. Here is our roadmap for today. We'll start with number 1, inside the AI brain. Then 2, the training pipeline. 3, tokens, the building blocks. 4, the prediction engine. 5, comparing top models. And finally, 6, real-world use and a quick glossary. Okay, section 1, inside the AI brain. Let's lay the foundation. A large language model, or LLM, is essentially an AI system trained on a truly unfathomable amount of text data. But here is the absolute most important distinction to make right up front. The AI does not think like you or I do. It doesn't have thoughts. It doesn't have feelings. Instead, imagine an entity that has literally read the entire internet. By absorbing all of those books, articles, and websites, it has become the ultimate pattern recognizer. It uses those massive language patterns to mathematically predict what word should naturally come next in a sequence. And to pull off that kind of ultra-advanced pattern recognition, the scale has to be staggering. We are talking about hundreds of billions of parameters. Take OpenAI's GPT-4, for instance. It uses well over 100 billion parameters. You can think of parameters as tiny adjustable dials or even synapses in a digital brain that track the endless intricacies of human language. It's this sheer, mind-boggling scale that transforms basic pattern matching into something that feels remarkably like genuine comprehension. Moving on to section 2, the training pipeline. How do we actually build one of these things? Building an LLM is basically a 4-step educational journey. Step 1 is data collection. This is where the model gathers its reading material, all the books, code, and web pages. Step 2 is pre-training. Imagine sending the AI to a school that houses every text ever written. It spends months there just absorbing raw grammar, facts, and reasoning patterns. Step 3 is fine-tuning, which is where it specializes in specific tasks, like formatting an email or writing Python code. But step 4? That's the real game changer. That final step is called RLHF, which stands for Reinforcement Learning from Human Feedback. See, raw pre-training just gives you an AI that can spit out internet text. And let's be honest, the internet isn't always the most helpful or polite place. RLHF is the behavioral training. It uses actual human graders to teach the model to favor responses that are safe and genuinely helpful. This is exactly what transforms a raw data engine into the polite, useful assistant you chat with every day. Let's look at section 3, tokens, the building blocks. This is where things get really fascinating. We need to clear up a major misconception right now. You and I read words and sentences, right? Well, AI models don't. They read tokens. Tokens are these small chunks of text that the LLM processes. Think of them like puzzle pieces. The model doesn't look at a sentence as one complete thought. It breaks the sentence down into these tiny puzzle pieces, analyzes them, and then snaps together new puzzle pieces to generate your response. Let's actually visualize how tokenization works in practice. A short, very common word, like ChatGPT, is usually processed as just one single token. But a longer, slightly more complex word, like generative, the model might chop that into 2 tokens, maybe gen and erative. Meanwhile, a short phrase like I love AI breaks down into 3 distinct tokens. This is the AI's true native alphabet. It's constantly analyzing and predicting sequences of these specific chunks, not full English words. And that brings us to a massively important concept, the context window. The context window is the maximum number of tokens the model can hold in its active working memory at any one time. GPT-4, for example, boasts a massive 128,000 token capacity. To put that into perspective for you, that means it can process, remember, and analyze the equivalent of an entire 300-page book in a single prompt without forgetting what happened on page 1. It is a monumental leap in how much data we can feed these models all at once. Which leads us directly into section 4, the prediction engine. So we have this massive training background, and we have our token puzzle pieces. But how does the AI actually generate a response? It all comes down to next token prediction, which is powered by something called the attention mechanism. When you give the AI a prompt, it uses this attention mechanism to weigh which previous tokens are the most important, and then it mathematically calculates the most likely next token. Then it does it again and again. It's essentially like the autocomplete feature on your smartphone, but on absolute steroids, trained on the entire internet and running billions of times a second. Here is a highly actionable tip for you. You can actually control how it makes these predictions using a developer setting called temperature. If you turn the temperature dial up high, the model will occasionally pick less obvious next tokens, which gives you highly creative, imaginative, and varied outputs. But if you set that temperature low, it plays it safe. It consistently picks the most probable next tokens, giving you highly precise, factual, and repeatable results. It's just one simple dial, but it completely changes the model's personality and behavior.
All right, Section 5, comparing top models. Let's look at the actual landscape out there.
Because of different training methods, each of the big models out there is optimized for distinct strengths. GPT-4 by OpenAI is widely considered the absolute powerhouse for general tasks and complex coding. Then you have Claude, developed by Anthropic, which is highly optimized for processing really long documents with a massive emphasis on safety and nuanced understanding. And Google's Gemini highlights a huge emerging trend, multimodal capabilities. That means it's designed from the ground up to seamlessly process text, audio, and images, all at the exact same time. They're all LLMs, but they each have their own unique superpowers. Finally, Section 6, real-world use and our glossary. How is this actually changing the game? The applications for this tech go way, way beyond just casual chatting. Right now, as we speak, software developers are using LLMs to debug incredibly complex code in seconds. Marketers and researchers are leveraging them to draft content, summarize massive 50-page reports, analyze data sets. Businesses are automating their frontline customer support and even setting up personalized education tutors. Companies are seeing a massive, massive boost in operational productivity simply by dropping these tools into their daily workflows. Let's lock in what we've learned today with a quick, rapid-fire glossary recap of the two most important terms from our journey. First up, parameters. Remember, these are the hundreds of billions of internal dials or settings the model adjusts while it's training. They are the literal physical representation of the language patterns the AI mapped out while reading the internet. And second is the context window. Think of this as the model's active working memory. It is the maximum sequence of tokens an LLM can process, remember, and pay attention to at one single time. The larger the context window, the bigger the document or conversation you can feed into the AI without it losing the plot. So if you take nothing else away from this explainer, remember these 4 core architectural takeaways. 1. LLMs do not think. They are trained on massive amounts of text to learn and replicate patterns. 2. They don't read words. They process little chunks of text called tokens. 3. They generate answers by mathematically predicting the next tokens using an attention mechanism. And 4, while the underlying tech is similar, different models like GPT, Claude, and Gemini have distinct, powerful strengths. I really want to emphasize the sheer scale of what we are witnessing right now. LLMs are not just novelty chatbots that can write you a funny poem. As this architecture shows us, they are the foundation layer of modern artificial intelligence. They are the vast, unbelievably complex engines that are going to power the entire next generation of software, research, and human communication. We have just walked straight through the digital brain of a large language model. You know exactly how the training, the tokens, and the prediction engines all interlock to create the backbone of the AI revolution. The underlying technology is here, and the architecture is set, so the only question left for you is which LLM will you choose to build your future with. Thank you so much for joining me on this explainer. Drop a comment below with which model you use the most, and as always, keep learning.